you get the links to them? I didn't know if it sent them. Has Mr. Gaddis already sent you the finals?
Not the final exams, but the last test.
I don't even want to see the last test. I really don't. I didn't know if you saw the final, whether or not it was going to be hard or not.
No, I probably won't see it till that day.
Because I don't want to get too comfortable with the fact that it's multiple choice and that it'd be really difficult, like the math competition.
Yeah.
But except we're supposed to know this stuff, so that would be kind of an issue. Are you ready for review? Thank you. I don't want to open it.
I don't either.
I already know how much it dropped my grade.
Maybe it dropped it like 1 point. I mean that's better than previous tests.
That is better than previous tests.
It is. You've seen all of my 30s. I'm surprised my grade isn't like at a 30.
Wow. That's actually impressive. How you can turn 30s into 70s?
Oh dude, I'm impressed.
How about Oh my goodness, I got number 2 completely right. Oh, yeah.
A great day. Is it easy to do well?
B is clear. Because this would work, except that this is, it has an asymptote.
Right.
It has to be What did I do? Okay, I knew I messed
Hey,
up.
I almost got this one all the way. That's what I thought it was.
I literally forgot to put the little mark for the prime, for the direct, the mark. A whole point off for that. No.
I got some points on that.
I know.
Hey.
I felt pretty good about those. I'm glad I got those right.
Wait, so how do you get -4 over?
Did you make sure that you?
Okay. Did you guys get number 4?
Yeah.
What is it?
I got most.
How well did you do on the final? Like the first?
What do you mean?
Like
Jeez, Chloe. Way to one up all of us.
So happy.
Do you see this?
It's the best grade I've gotten in this class. Except for the lab
Mine was
grades.
on like the second test we took, but just right from there.
Okay. What about 10? Does anyone know how to do number 10 then? Yeah, it's got the how we had to graph using the absolute.
I got 11 all the way right, and I thought I wasn't for sure on that answer.
Nice.
Wait, how did? Oh, mine's too high.
Why did he mark off a point for this one?
The area between, not absolute area.
For the area between where that's basically the absolute area.
Hey Sammy, how did you graph number 2?
You got me on a technicality.
Nice.
I told you, I didn't even do 4 of them.
Well, I didn't do like the bad questions.
Wait, what did you get on that one? You got the majority of it right. So how did you?
Hi. What is it? Is it just?
It doesn't make sense. I got that one.
Way go.
Wait, what did you get for this one?
That.
What?
It's
How?
a W. Why? Because I didn't want to leave it blank.
Amanda, can you hear me?
I can.
Okay, everyone. Our tech is not in, so I'm trying to figure out how to.
I
Yeah,
know, but
hold on.
when I looked at
Apparently Joe's not there.
Oh no.
Yeah, I was.
It's gonna be
Share
Good job. Okay, how did you do 14?
Did the Steelers win soon?
Yes.
That was, we won in the last couple seconds.
Oh yeah,
Oh
that's
my
it on your story.
Oh,
Oh, I didn't even press it.
You know,
it's like I just wrote down the steps and then I plugged it into the calculator.
this isn't
How?
even,
I don't know.
this isn't even their most stressful game. There was one season that
Did you read it?
the fans actually had heart
Oh my
attacks
goodness.
watching the game. And one kid had it game while they were playing and he refused to leave until he knew they won.
It's you.
That would be me. I was freaking out.
They're just, this is weird. Stressful finals.
And not to mention, all of the good players were out pretty much.
Really?
We still had two of the good ones. Well, good quarterback. I mean, he's a good quarterback, but after he was in a motorcycle accident, he's kind of gotten worse.
Well, yeah.
He wasn't wearing a
Sammy.
helmet.
Yikes. Why
That's
did
his
you
own fault.
So,
That's his own fault.
he can throw really well, but he's thrown a lot of interceptions this season. Well, anyways, the other players that we needed, Ryan Shazier. Yeah, I'm really upset about that.
It's okay.
Well, Ryan Shazier is our leading tackle. And during the last game, he went in for a tackle with his head down, and he did something to his
Did the
spinal
Steelers
cord.
win?
Yes. I'm hoping we go to the Super Bowl. We just have to beat the Patriots now. I can't stand the Patriots. And this is when me and Carson aren't friends anymore.
Oh yeah.
Because he's a Patriots fan. That's not right. But anyways, Ryan Shazier was airlifted to the hospital in the last game, and they don't know if he'll be again. He's probably not going to be again, but right now it's like 3 days after the
I know.
injury.
That's all we gotta do.
What
So-
happened?
No,
He
when
went
is
in
it
with
leaving you?
Went in
Yeah.
the tackle with his
1
head
point.
ducked down instead of ducked up.
That's good.
And yeah, and then his replacement got injured directly after that. And then during that same game, one of the Bengals players was airlifted off the field for an injury. And then one of our really good drafts, Juju Smith. I mean, he's good, but he's one of those really bad. So he tapped the other guy that I said from the Bengals that got airlifted. Juju's the one that tapped him. Instead of just tackling him and then letting him come, he stood over him as kind of a haha kind of thing. And I was like, that is disgraceful. So he got suspended for a game.
Well, yeah.
And I was freaking out. I was about to have a panic attack. I'm literally sitting, and if I read my texts with my aunt, who's also a huge Steelers fan, it's like, oh my goodness, we're gonna lose. Wait, we have a chance. No, we're gonna lose. Wait, here
Do
we
you
go.
have family in Pennsylvania?
Yeah, my mom's from Pittsburgh, and all of the family is live in Pittsburgh for the most part.
Is that why you're Steelers?
Yeah, and my dad's a Dallas fan because
Nice.
that was back when they didn't have the Panthers, and they had to choose between like the Steelers and Cowboys, so he chose the Cowboys. But he doesn't really care about football. He doesn't understand.
This is a great day. I think we should just stop.
But the Patriots have a game today, and then we'll be playing them in the next future to see who goes to the Super Bowl. We need to win the Super Bowl. So far we have the record number of wins, but the Patriots have catch up. I am very concerned. So we won 6 and the thing is called like steroids. And even have the fancy little Steelers hat and jolly.
Just that is
We got 4 more days.
The
Carson.
score.
That's so close.
Fortunately.
Yep.
3 more days.
Because
you made it today.
That A was
3
correct.
more
You did the interval. negative
more
1
days
to
of
1
disappointment.
is 0, so the
And
denominator
depression.
of x squared would be equal to 0 at 0. And you can't divide by 0, 0, and because it's over 0, that means that f of x is not continuous, so the fundamental theorem of calculus is not.
Yep, we play the Patriots next week.
Yeah, that sounds good. Okay. I did all the math right. I just missed the front page.
Is college
What's
football?
the words?
Huh?
Or
I've been too obsessed with the Steelers to worry about college football.
did you get
My dad's been watching all the state games.
I think that no.
Okay.
I was partial.
I know state won
I didn't
against
study.
David.
Is that down lost by
I remember what to search for. I searched for NC.
It's
and
from
it was M's.
I think it's from you.
I didn't understand football
What?
until my aunt took me to
What
the
did you
season
do?
game.
Um,
Steelers and Panthers, and she was sitting there teaching me. I was like, oh, this is actually
Probably once I
interesting.
got that, then figure out how to hold on. What was it?
That was great.
I got the cursor for NC. I couldn't go delete. I'm like, well, how do I get back to the end?
I wouldn't.
Yeah, I just want a regular keyboard with an end button and stuff.
That's what
I
did.
took
but still-
notes.
Well, would you do the divided by the
Yes.
Yeah, but it didn't. So
Yeah.
There's no
Hey, Chloe,
They
did
can
you
not.
go back and do?
I did.
I haven't done anything this weekend.
The question was just now,
For the final?
Yeah.
question, I guess one question was, we only pre-calculus review chapter, which was the initial chapter we did, the chapter 0. Will that be on the final exam? And the answer is no. The final exam will only be calculus material. And then the other question that I got over the weekend was how many questions are we looking at? And the exam is 30 questions. 15 on the first day, on Wednesday, and 15 on Thursday. And it's multiple choice.
Did you guys do that?
Thank you.
13 mark, there's
Well, each
15.
one tests like 12.
True. But he said
Okay.
It was multiple choice.
it was a
That
right or
hard.
wrong. So if
Because
you
don't get
guess
any
and you
partial
get it
credit.
right,
I'm
you get
relying
full
on that
credit.
partial credit.
But if you
At least
guess
I
and you
didn't
get it
get
wrong,
completely wrong.
Another question about the exam. I want to talk about this test board as well, but for now, I'm just asking questions about the exam.
Pass this one.
can you
Forgot
explain
my
anything on the test that we got wrong?
last semester.
So you know that when you sit over there, it's not
Well,
sure.
What I want to do is, since we're not doing a rework, you don't have a week to do your rework and study the test, I want you to be able to hang on to the test and use it as a study tool for your exam. But that means you need to have some good answers. So I want to kind of go over the test some today on some of these problems, so we have a good foundation to study on for the final exam. So I think I shared this PC
You
already.
share it.
So that's what I'm gonna do is just go through some of the topics on the test, and have questions or whatever. We can talk about it. So first off, topic number 1. Most people did fine on because you knew that it was coming, and so most people did fine on them. I don't think I need to go through that. Unless there's a specific question. And the statement of the theorem is in the book. There's a proof in the book. We also have proof in the notes. So I don't think we really need to go over that. That's just a specific question. Now, number 2, the choices A or B as being the thing that was wrong. And it turns out that part A is incorrect. And if you at least stated that, I gave you 4 points for that. But then the explanation is what was needed for the rest of the on that. So let's take a look at number 2. It gives you an integral, and then on part A, use fundamental theorem of calculus to get a negative value, and I showed the work of finding an indefinite integral, which is indefinite integral of x to the negative 2 is negative x to the negative 1, using the power rule. And then if you apply the fundamental theorem and substitute in the endpoints into that antiderivative, and subtract them, you do get a negative 2 response. However, that's incorrect. And it's pointed out that it has to be incorrect in the second statement, part B. We learned about Riemann sums that you get a signed area using a Riemann sum. And since this function, 1/x squared, if you graph it, is always above the axis, and we're going from left to right on the interval -1 to 1, then according to the Riemann sums, it has to be a positive response. And in fact, it might even be positive infinity, as is in this case. So actually, 1/x squared does have a finite here. Okay, but so part B is true, absolutely true. Part A is wrong, and why is it wrong? So if you apply the fundamental theorem of calculus, you get a negative 2. That's really wrong. So something about the fundamental theorem of calculus must be wrong, or cannot be applicable here. So why is it not applicable on this function? Sammy?
Because there's an asymptote, it's not continuous on the interval.
Yes. The fundamental theorem of calculus starts off with a hypothesis. If f is continuous on A to B, okay, that's the problem right there. It's not continuous from -1 to 1 because it's discontinuous at 0. So it's discontinuous at x. And 0 is between -1 and 1. So I cannot apply the fundamental theorem of calculus as it's written. However, in Calc 2, we learn how to do that integral. And interestingly, the integral from -1 to 1 of 1/x squared, while there is a vertical asymptote, and this is a kind of a mind blower, at least in my mind. So imagine finding the area, just real quickly. We're not going to do Calc 2 today, but just imagine trying to find the area. You got to, as Sammy said, a vertical asymptote. So this function, 1/x squared, gets close to a vertical asymptote. It means it gets very tall. So your rectangles will have very tall heights. In fact, as you get closer and closer, they get infinite height. But function, if I'm remembering correctly, I have to look into it, but we ought to be able to show that it has a finite area, even though it has an infinite height. That's anyways, that's Calc 2. Now on to the next problem. Number 3. Use the fundamental theorem of calculus. First of all, why can I apply the fundamental theorem of calculus on number 3? It's discontinuous square. This at x equals 0. But 0 is not in the interval, so I'm okay. So most did okay on this, but if you didn't see it, the easy way to handle it is to split this into 2 fractions. X divided by x to the 1/2 is x to the 1/2. And then 3 divided by x to the 1/2 is 3x to the negative 1/2. It's easy from there. What do you get? I think you go through all the work of this. get -4/3. Question number 3. How about number 4? Again, the fundamental theorem of calculus applies because it's not discontinuous anywhere. So we can easily do number 4 with the fundamental theorem. I think the easiest way to do this one is to factor out that 5. Now, that's easy. That's just an inverse tangent. So this is just 5 times inverse tangent. And that should give you 5/4. Questions on number 4? How to achieve number 4? Inverse tangent of x. On number 5, how do we do it? Any suggestions here? First one, number 5 is discontinuous on x equals 1/4. So we can apply fundamental theorem here because this continuity is not in the animal. Factor out the 2. You observe there. What does that look like? The derivative of natural log of 4x minus 1 equals 1 over 4x minus 1 times the chain rule derivative is a 4. So if I divided the 4 to the other side of that equal sign, it would be where I want. So this would be 2 times 1/4 of natural log of absolute value of 4x minus 1. So you get a 1/4 factor in there because of the chain rule. You get a 1/4 factor. And the final result comes out to be 1/2 of natural log of 19 minus natural log of 3 or natural log of the root 19 over 3. Questions on number 5? And I'm just trying to give you some facts so that you can use this to study for your final exam. Since you don't have a lot of time to do that. Questions on? Good to go. Number 6, find the C value guaranteed by the mean value of intervals for this. What does that mean, the C value? So it said there's some C element of -1 to 2 where f of C is equal to average value. Let me just comment, folks. This problem number 6 on the test is precisely one of the ones in the homework in the textbook, and we did it in class. Did the whole problem in class the day before the exam test. So first you want to find the average value. And that's just the interval from -1 to 2x squared plus 1 divided by 2 minus -1. And we went through that, like I said, before the test. got 9 over 3, which is 3. So then we use that 3 to find this. We have f of c equals 3. So c squared plus 1 equals 3. Means that c equals plus or minus 1. But we had to choose c equals plus 1 because negative 1 is not in the interval for this. It has to be open. And then number 7, explain what's all going on here. And we did this last time. 2x squared plus 1 looks something like that. However, we're not using. Let's go ahead and that. So this will be -1. So there's 2. And what we have figured out is that a height of 3 right here. There's a 3. And that's a height of 3, and it's a width of 3. 3 by 3, 9 square units. That's the same as the area under the curve. And this number 1 is right there. There's a 1. One average value. And a single rectangle at that height. The whole area. Okay, so again, we did that problem in class, precisely that problem. Number 8, find the signed area, absolute area. That should have been intended to be a really easy problem. Part A is just signed area, which is just the interval from 0 to x squared minus 1 dx. And that should come out to be 2/3. And then part B is the absolute area, so that's just 0 to 2 at 5 x squared minus 1. To remove the absolute value symbol, you have to find where it's equal to 0, so you can know when the function is above or below the axis. And that occurs once, so we have to go from 0 to 1. And 0 to 1 is below the axis, I guess, so we need to take the negative of it. Then from 1 to 2, it's above the axis, so we don't need to take the negative. And if you follow that path for a little while, it gets to 2. Okay. Absolute signed area should have been an easy problem. Most people did fine. You got a whole loss. Area between is the same idea. So you're doing the interval -3 to 5. Absolute value of subtract either way I want. It doesn't matter. I'm going to choose to subtract g of x minus f of x if I feel like it. And that simplifies to an absolute value cleared minus 4x plus 2x minus 2x, and 4 minus 7 is minus 3. Now, to take off the absolute value there, you have to split it where that function is 0. That would be at, where's that 0? -1 and 3. So, 1, and let's see, g of x parabola, f of x is the line. Outside, parabola is 15 the line, so this is positive, I think. And then negative between. Positive on the ends. Split it up into 3 intervals, and if you follow that path for what we call a simple power rule, you should come up with an answer of 32. You have to split it at -1 and +3, and look at when each of those is positive sections of negative. Number 10. Well, I'm giving you a graph of f of x and asking you to draw a graph of the area relation. So I start off right here, there's 0 area. By the time I get to x equals 0, I've accumulated a little more than half of a square. By the time I get to x equals 1, I've accumulated a little more than a half. So I'm a little more than 1 there. There's a little more than half. There's a little more than 1.
Oh.
I'm just looking at the size of the rectangle. See that? Oh. There's right there a little more than half of a square shaded in. Would you agree with that? And then there's another little more than a half of a square shaded in. Now I'm going to take off a little more than half, maybe 3/4 of a square. So my mark needs to come down from a little over 1 to maybe just barely above the axis somewhere right there. Then I'm going to take off like more than 2, maybe about 2.5 off of that. So, off the flesh. 1, 2, 1, 2.5, maybe about right there. And then I'm taking off, looks like over 3, a little more than 3. So 1, 2, maybe right down in this. The next one looks like I'm taking off area of this almost 1 right there. That's going to make up the difference to a 1 right there. So a little more than 1.5 to 1/3. So somewhere down in here. And then I start adding a bunch of area. That's a little tough. Let's see if we can do it. This is almost 1 whole one right there. I would say that adds right that one right there is going to add up to another. That makes it 1. This one plus that one makes 2. And this one plus that one makes 3. There's about 3.5 in there. So 1, 2, 3.5. So I just connect these dots. Something like that. Questions on number 10? Anyone? How I was thinking my way through that? Present?
So a of x is the antiderivative of that function, correct?
Yes. Area accumulation as antiderivative.
Wasn't there a thing where, like, when the original function has its vertex, the derivative function crosses the x-axis or something like that because the slope is 0?
Yes, but again, this isn't area accumulation, so it's a little.
It's a little
I see what
different.
you're saying. I see what you're going at, but I was looking for area accumulation on this one.
All right.
Okay. So what about number 11? That's easy. So you just plug in this into t based on the derivative. So this is just sine of x squared plus 3x minus 1 times the derivative of that, which is 2x plus 3. Number 12 is easy. Most people did fine. Okay. Average height is going to be double 0 to 7. 0.21x squared plus 0.13x. X divided by 7 minus 0. And if you go through that, you should get 3.89 centimeters as an average height. And then the average rate of change is simply the change in height, so h of 7 minus h of 0 over change of time. This is change of height over change of time. And if you go through that arithmetic, you should get 1.60 centimeters per rounded to the hundredths. Number 13. A couple of people got number 13. Something totally different. We've heard that. You like it? I give you a big hint. You got to take this fraction here and split it in 2 fractions. Basically, if you add these 2 fractions together, you're going to get a times x minus 1 plus b times x plus 1 over x squared minus 1 has to equal 3x plus 1 over x squared minus 1. That means that a x plus bx minus a plus b. That's equal to 3x plus 1. So now pick A and B, or set up a system of equations and solve it. So if you look at the x coefficients, you have a plus b equals 3. So that came from x coefficient and x coefficient have to be the same. And then if you look at the constants, another equation, negative a plus b is 1. And if you solve that simultaneously, you should get a equals 1, b equals 2. Now, if you didn't see all that, you could have just guessed and checked for an A and B. One, Berkshire made it just 1 and 2, so there wasn't too hard to find. Guess them. Once you know that, now you can split the original interval up into 2. Now the interval from 2 to 4 of 1 over x plus 1 plus the interval from 2 to 4 of 2 over x minus 1. And that's not too bad. Those are just natural log results. So if you go through this for a little while, you should get the natural log of 5 plus the natural log of 3. And that's the natural log of 15. Last question. This was similar in some ways to a problem we did in class. Remember the Wally burger problem, the upside down McDonald's? Basically, this is like that. In order to find the area, you have to recognize that if you're going to do like a top function minus a bottom function, then you have to split this area into 2 regions. In this region here, x is the top of my forming rectangles. Get started with so when I form a rectangle in here, g of x, f of x form the top and bottom of my rectangle. But in this other region, over here, then it turns out that the horizontal line at y equals 2 forms the top and f of x forms the bottom. So we've got to literally split this into 2 pieces like we did with the w. The red region is going to be the integral from -2, looks like it starts off right there. So it starts off at -2, ends at 1. So -2 to 1. And the upper end. So instead of doing absolute values, I'm just going to do the big function minus the small function. So the big function is 2 to the x, looks like g of x, and then minus the small function 1 to the x squared minus 2.
But could you not do it the
And if you go through that for a little bit, you should get, I didn't work that out separately. I guess you can kind of work that out. Okay. That area is going to be x divided by log of 2 minus, if I raise the power, divide by it, that's going to be 112 of x cubed plus 2x divided by -2 to 1. minus 2 over log 2, that's like minus 112 plus 2 minus. So then a negative 2 is 4, so 1 over 4 log 2 plus 12 is divided by 4 is 2/3 minus 4. So negative up here. Oh, let's see. That's 8. So that's 7 over 4 log 2. And I've got 2 plus 4 is 6. Thirds minus 2/3 is 16/3. So there are 12, so then 1.4 is 64. 12 minus 1 is 63. I think that's 63 12s. I want to double check that. 12. I think that's right. Okay, so now the blue area. We do integral from 1, looks like it ends at 4 out here, so 1, 4. And the upper limit, upper bound of the region is 2. And the lower bound is the f of x. So it's 1, 4 x squared minus 2. Let's see, 2 plus 2 is 4, so we get 4x minus 112x 1, 4. So that's equal to minus 64 over 12 divided by 4 is 16/3. That's not plus. Or minus 1. Whatever that is. Then add those two numbers together. 48 minus 16 is 32/3 minus 12/3, 20/3 plus 12. Third minus 12. I think I get 79/12. It's number one. I'm not sure about that. Then add those together. Should be my answer. $63 over here might not be right. That might be 61. Might come wrong with that. Anyways, that's how you should be doing it. Any questions on any of this? Now you have some solutions that you can work with on this test. So we have a final exam coming up on Thursday and Friday. Once again, that is questions on, not Thursday, Friday. I meant Wednesday, Thursday. 15 questions on Wednesday and 15 questions on question on Thursday. Roughly chronological, and no chapter 0, which was the pre-documents. That's it. What questions do you have?
So like none of that, if there's an X, then there's a Y that does this?
Correct.
Okay. That's good.
Okay, I have a question.
Chloe?
Do you think a good way to study would be going back over our old test?
I think that would be a good way to study. I would also look at homework problems as well from the textbook. I think you can call up the computer share. I think going over homework is also a good idea from the textbook, because the final exam, again, being multiple choice, is actually one that's provided by the publisher. So the questions are going to be like what's in the book.
Nice.
Thanks.
Probably not cool though. That would be worse.
It is multiple choice, but I'll go ahead and forewarn you. Every question has one of its options. None of these.
Oh no.
I hate those.
More again.
That makes me doubt myself.
Don't doubt yourself. Believe in your abilities, Chloe.
One good way to study might be to pull out a homework problem or something and say, how can I make this into a multiple choice question?
That's fair.
We've done all of our work on our tests as open, meaning I graded on partial credit. And if you made a small mistake, then you got a lot of partial credit. If you made a big mistake, you didn't get as much partial credit. But now you're not going to get any credit unless it's correct. So how do you make a good multiple choice question out of a task question? Personally, obviously my personal opinion is I don't agree with multiple choice tests, especially math. But since it's the final exam and we have to collect all kind of assessment data, the easy way to do that for us in the math club, and me being the draft chair to do all that, is to make multiple choice tests. So that's what we have. But how do you make a good multiple choice question? Meaning, to be a good multiple choice test question from an educational standpoint means that you have to have not only the correct answer there, or maybe not, but you have none of these, but you have other answers that are called good distractor answers, meaning that, it's a common mistake that students might make. Rather than just making up some random number and throwing it down, it's oftentimes something that's a common mistake. So that would be a good exercise too, is to work out a problem, come up with the correct answer, and then think, well, what kind of mistakes, what would I be wary of, if I'm looking at these options of answers on my test.
All right.
So that's all I have on the exam, so it's just a matter of if you have comments or concerns, issues that you want to go over, examples or something like that, we can do that.
Well, I kind of already. Oh yeah, I have a question.
Okay. Yes, Reza.
Was this gonna be like a Scantron thingy?
Well, most of them are Scantron keys. But with this situation of having to email back and forth, I'm probably just going to have you circle the answer on the test.
Okay.
Are we having to go through the old version and have the option be the long version?
Well, I don't honestly haven't looked at the questions on the test, but The test is a math department common, like every calculus class, Calc 1 class takes this test. So I haven't really looked at the questions, to be quite honest with you, but I feel certain that some questions are going to, although you are not required to use a particular method, to find a derivative, you can take all the shortcut rules, because it's just getting the right answer. But again, you can have questions, I would think, that could, in some ways, test your knowledge of definitions and the full-long method. How that would look, I'm not sure, but I would think it could be. But I'm not going to give you test questions. That's Josh.
Are calculators allowed on the test? Or
Yeah,
exams?
Sleep. Oh, good. I see all. Oh yeah, that is.
And calculators have mostly figured out that you can do a definite interval on your calculator fairly easily.
What did he say?
He already knows.
You can do definite interval.
Oh yeah, I found that out a bit late, and it made me really sad.
Evaluated at
The TI-89 can do it symbolically and give you an antiderivative symbolically, but all of them can find a numeric value of a definite integral, assuming that it's got a numeric value.
Yeah.
So the way you do that, if you're not familiar, some of you may not be yet, so I don't generally show you that because I want you to do it the long way. But now that it's possible, so let's go back to the computer for a minute. So let me.
all three of my notebooks.
Here's my calculator. Let's see if I went in here to my. There's a couple different ways to do it, but one simple way is to put in your function. So we'll just put in x squared plus 2x, whatever. And then if we graph that, got a picture of it. So let's say we want to find the definite interval from -2 to +2. So let's see, then I have to go into this calculator. I go to second calculator up at the top. Some of you choose math, but it's hidden in there somewhere. And on this one, in that first thing you want to calculate, I see an integral symbol. And they're actually showing it, from our books, indefinite interval, but it's actually going to calculate a definite interval. And then ask for a lower limit, so I can either use my arrow key and scroll over to it, or I can just type in -2. And then I want an upper bound with +2 I decided. I put that in. It even shades it.
Oh my god.
Oh, that is magic.
Why did you know that?
Why did we not know this?
Yeah, Chloe.
Why did you say that?
Well, somehow I imagined, I amazingly forgot about that until just today. Now I suddenly remembered.
Oh yeah, I forgot we could completely automize the process through a device we've been using the whole class.
Why would we want to learn the shortcuts when we can have fun doing the real things?
Oh yeah.
Now that it's final exam time, if you want to use your shortcuts, there you have it.
We only does 10.
I don't know of any before they will give you an in-depth one. I believe the 89 can do that for sure. What else?
Can I ask you for a content-related question?
Go ahead, and I'll decide if I can answer.
Can you go over an optimization question and a related rate question?
Wait, go over the
Sure,
numbers.
if you pick one, I'll do it.
Okay.
Numbers is
Which one? The one with the
the one that no one got right on the
trig question?
Yeah.
Yeah.
Wait, what?
We're gonna put later, right?
What test is
What was the one that one
Here it is, test 7. Which one? Is
It's
this
the one with the tangent.
It was
the TV camera, number
Yeah.
5 on test 7? There you go.
Okay.
Don't bend my pages.
It was block 7.
Mr. Gaddis.
Also, rivet in there too.
Mr. Gaddis.
Oh, yes.
Should I?
Again, that's going to give you a number, so that means the derivative evaluated at a point. Finish at 89. That's great.
Can you go over number 5 on block 7 test?
Yes. Does anybody here have a block 7 test with them that I can look at?
I'm holding it. Do you want me to verbally
Well,
communicate
yeah, let me
it?
see. If one of these have it, that will be easier than that. What number was it on block 7?
Does it still look at me?
Yeah.
Please stop looking at me. Okay.
One with the race car?
Yeah.
Yes.
So, I put that on there just for the Davidson folks, because I mean, that's over there in your territory, isn't the big race car thing they're going on there? Like, one of the drivers, don't they have a big?
We don't really have a big
How do we get this one? TV camera.
Get Daniel Bonifest.
Have a picture. I even gave you a nice picture. Here's my TV camera. Here's the finish line. There's a car. Is that way. Pointed at the car. I don't know if that black is dark enough anymore. I have to keep it down. I'll take the worst. That one. That's me. Okay, so I even said that let's call this distance from here to here. Let's call that distance x. This angle in here is theta.
Is this a related
You're given that this distance here, 150 feet. Let's see, approaches the finish line at 180 feet, 180 miles per hour. So the dt, 180 miles per hour. What we're supposed to find, so that's what's given. What we're supposed to find, marker that has statements. Find what we're supposed to find. Rate of change of the rotational speed of the camera. So d theta dt, the guy weighted at, or it's 20 feet from the finish line, so x equals 20. And then also told you how to convert it by giving, or that you needed to convert, because I gave you the conversions. So this is miles per hour. If you multiply that by 1,280 feet per 1 mile, multiplied by 1 hour for 3,600 seconds. What number do you get? That's 264 feet per second. I didn't tell you how to convert, but I gave you the conversions, which is a pretty good indicator. So we're given a rate of change of the automobile approaching the finish line. And we want to know the rate of change, the rotation of the camera as this happens.
Mm-hmm.
I guess we need some kind of an equation that relates theta and x.
No, snap.
What would that equation be?
It's going to be sine or going to be tangent? Is it going to be tangent? It's probably
I'm
going to
going
be
to go
tangent.
with tangent simply because I could do sine, but I'd have to know this side, and I could find it in relation to this by Pythagorean theorem, but that's just extra work, so I'm going to go with tangent. Say the tangent of theta is equal to x over 150. So if I differentiate that, and there's a couple different ways to do this. I'm just going to leave it as is. Some people took the inverse tangent and just got theta by itself as a function of x, which is fine. That's not wrong. I'm just going to keep it simple and differentiate both sides of this equation with respect to time.
Oh, that's nice.
And so the derivative of tangent of theta is secant squared of theta. But then times, because we're differentiating with respect to t, then this is a chain rule. That'd be d theta dt. And then the derivative of x over 50 or 150 is just 1 over 150. But then times, we're differentiating with respect to t, so that's dx by dt.
Yo, we know what dx over dt is, though.
I already know that. So all we have to do is solve for d theta dt. So d theta dt is what we're looking for. That's going to be 1 over 150 secant squared of theta times dx dt. We know dx dt already, that's 264 feet per second, and this is 150 feet. So the feet cancels, which is good because we want to get into just radians. But now we need to know what secant squared of theta is. How do I figure that out? X is 20. So we now got this triangle here. Here's theta, that's 20, that's 150. So you figure out secant of theta from that. Secant of theta is equal to reciprocal of cosine, isn't it? So that would be like whatever that side is divided by that side. 150 squared minus 20 squared. So the square root of 150 squared minus 20 squared over, and then the square of that would be minus 20 squared over 150.
Got him.
So that goes in here. Theta dt evaluated at x equals 20 is equal to 1 over 150 times 150 squared minus 20 squared over 150 squared times 264. And whatever that is. That is the actual. But, I mean, it depends. Sometimes we're going to be looking for a decimal response. There'll be decimal choices. Sometimes we're looking for an exact response. There'll be exact response choices. So the answer choices on the test, the question is kind of, and sometimes there'll be exact responses. Sometimes they may be decimal. Is that the old deal? Answer your question, Ray. If you follow all that?
Yeah. I just want to know if I got a good decimal.
I don't know. Let's get a couple people to share their answers and make sure that we got it right. Anybody get it right on the original test? I don't know.
Well,
Maybe.
that's okay.
I don't remember.
I got 1.79.
Yeah, that's right.
Okay. Guess that's right. You got 1.79, Mr. Gaddis.
1.79 radians per second. That sounds, somehow that rings a bell.
Yeah. Mr. Gaddis, another question.
Yeah. Let me do that real
Should we
quick. Go ahead. Go ahead, Reza.
Oh, should we expect like 4? Is it going to be like 4 choices per question, or is it going to be one of those tests where there's a lot of choices?
It's either 4 or 5 choices per question.
Okay.
I can't really see Sammy, but I can see a hand up. Sammy?
Shouldn't the point, or the 1.7, should that be negative? Since we're going.
Yes, actually it should be. Why should it be negative, Sammy? I agree with you. What did we overlook when we set this up? Well, and so what number up here did we also get wrong? Besides that should be a negative, what would have caused it to be negative if we had done it correctly? SDT, X is getting smaller, so this should have been negative here, and if you multiply by a negative there, you're going to get a negative answer. So yes, Sam, you're correct.
That's insane. Good job, Salome.
And then I have another question.
Okay, yes.
Can we go over number 6 on the same test?
Yes. Before we do that, I just want to mention to everyone, on this one, again, some people did it a different way. They went ahead and solved for theta, so let me just show you that real quick. So theta, if you solve for theta, it must be end of the semester. I refuse to go get a new marker. There's one. Theta equals inverse tangent of x over 150. Now, if you take the derivative of that, this just becomes d theta. We'll see that work for like 1 second. D theta by dt. And the derivative of inverse tangent is 1 over 1 plus quantity squared of x over 150 times chain rule of this is 1 over 150 times dx by dt. So you got to do the derivative of the inside, which is the 1 over 150, but then it wasn't just a simple, we're doing with respect to t as derivative, so you got dx to t, so double chain rule in there. Anyways, now you've got d theta dt already solved for at this stage, which looks very simple to this. But now all you do is plug in a 20 right there. You don't have to figure out what secant squared is. So that might have been a little bit easier that way. Okay, now number 6 on the same request.
I'm using biodegradable paper.
That's show everyone your grades on this. So number 6 on the same test. Then,
I like this one. I had like 3 Indian that helped me with this. And the reworks of the map form.
This dimension is 400 centimeters. This dimension is 60 centimeters. as is this dimension, as is that. It's an equilateral triangle. We're given, find the rate at which the water is dropping out, given that the depth of the water, so we'll call it dHdt. dHdt is equal to -3 centimeters per second, so it's dropping. And we're supposed to find a change in the amount of water, which would be the volume. When the height is 8.
Yeah.
Okay?
Mm-hmm.
We've got to relate volume and height somehow in an equation. You can use one. So volume in general is equal to area of the base times length of the object, which is just area times 400. But we need to convert area to something involving H. I'll point to that.
Base times height.
That's 60. That's 60. That's 60. And somewhere in here we have some water. So we'll call that distance right there H to the water. And we got to figure out the area of this amount of water right there. So we're going to use H somehow to figure out the area of the water. More triangles, okay, good, good. So I mean, the area of the triangle, don't forget, is 1/2 base times height. So let's see. We're going to do that. Similar triangle. We can figure out this height, the overall height of the triangle, the blue triangle, we can figure out fairly easily, right? By taking it or something. What is that? √3. And by Pythagorean theorem. Okay. So it looks to me like maybe we call this the little base right there. So ratio of little base to little height is 60 to 30 radical.
Yeah.
Base must be 2 over radical 3 times the height. That kind of makes sense. On a equilateral triangle, the height is radical 3 over 2 times the base because it's 6 degrees all around. So
Yeah.
if that's the case, then base is 2 just the reciprocal. That makes sense.
Mm-hmm.
Okay, so I can plug that in here. So I get area equals 1/2 times 2 over radical 3 times height, which is 1 over radical 3 times height squared. So my volume now is 400 over radical 3 height. Plug in that area over there. Now if I differentiate both sides of the equation, I get dV dt is equal to 400 over radical 3 times 2h times dh dt. And we're trying to find dV dt, so we've already got it solved. All we have to do is plug in h equals 8 and that produces dV dt evaluated at h equals is 400 radical 3 times 2 times 8 centimeters times dHdt is negative 3 centimeters per second. 400 centimeters also,
We're running out.
whatever that is.
Oh, you better hurry though.
Negative something.
Cool and nice.
11,000.
What'd you get salami?
Negative 11,085.
You know what? I don't know if that's right. I'm just gonna say it's
400
not.
times 3 is.
I got negative 11,000.
You got negative 11,000?
You gotta remember it's centimeters.
Awesome.
All right.
T.
Hey, that's what I got. Cool.
Try to get that. What does it come out as a decimal? I don't know, I did that rhythmically in my head, so I'm not sure.
That is the answer, Sammy.
It is?
Yeah, well.
No, that was really off. I got negative 27.
I don't think that's
What a
How's it
weird-
look?
what this is gonna be like.
You're at, okay. Well, I guess we're out of time today. We'll see you tomorrow. There's more of you. The review will continue in the same fashion. If you have questions, we'll try to go over those and work them out. Okay. See you all tomorrow.
Look at this page.
What about tomorrow?
Hey, final, the block 9 test. That's what a man's been waiting for. Oh yeah, so I calculated what I need to get an A for the final exam. I have to basically do perfect if I want to get an A on it.
Wait, you have to be perfect?
What?
Then that's no hope for me.
It's whatever, dude.
I've given up on the A. I'm just gonna go for a B now.
Take the B.
Guys, I'm making a low B at this point.
Okay.
There's no hope.
But you know what? It's still possible, so
Okay.
Not for me.
that's,
If Raisin has to make a perfect score where he's at.
no, I mean, a B is still possible.
Oh, we're done?
An A is really not that possible, but.
Awesome.
Because we don't have ready for college this week.
That's nice.
But tomorrow's our full day.
Oh, wonderful. What happens tomorrow? The Brit Lit and
And the
Chem.
chemistry.
Is
and
it just that
review.
the class time?
No,
What?
it's 9 until 11 for chem and then 2 until like 4 for lit.
It's pretty lame.
Which means we might as well just stay here.
Yeah, hey, I got a Christmas.
Can you guys turn
That's
the
not
lights off
very-
and pull the door shut? Really?
Yeah.
Raisa,
Huh?
turn the lights off and pull the door shut.
Okay, Miss Fuller.
Thank you.
You're welcome. I'm gonna go to Michael's today.
For what?
Because I'm gonna make a covert painting for my mother.
A what painting?
A covert painting. I'm gonna do it on the DL. Like she thinks I'm in the library studying, but on the down low, I'm in
You're
Jen's.
painting in the library.
I'm in Jen's garage painting. She'll
Oh,
never,
because Jim lives in your neighborhood.
yeah, she'll never see it come out.
That's what I had to do last year when I made my parents' presents. I like stayed upstairs for a while and they're just like, Brittany, do you need help with anything? No, Mom, leave me alone.
Got 'em. Got 'em.
You're figuring out what it is on Christmas.